Oh, well, good evening, everybody. Let's give maybe a minute or two more for more people to join in tonight. And first of all, thank you all very much for coming.
David, your mic.
Yeah, technical issues, even tech students have them. Anyways, let's give at least another minute for more of our fellow poly hackers to join in. And while we do that, we want to thank everyone who came in tonight. And thank you all of you hackers, for the past week. We know it's been very stressful, especially last night, since you guys had to submit your first submissions, and we have to also go through them. And it's also kind of stressful for us. So we're in this together. Don't worry. And, as always, before we begin, as mentioned earlier, we're going to be recording our sessions so you can access them later at a better time, because we know that our poly hack is designed to be global, not just for people at a certain time zone. Feel free to come back at any time. Now, with that out of the way, welcome, ladies and gentlemen, to Poly Hack Week 2, the week where you start building. Our very first technical workshop. And guess what? We have a very, very special speaker for you. Our first technical workshop speaker is Fadi Ibrahim. Let's give all a big hand. I know we can't hear you, but clap along anyways. Now, Fadi comes all the way from Cairo, Egypt, and he is our distinguished guest tonight. You may be wondering, why did we invite him to give us this talk? Well, that is because Fadi is a Google Cloud Champion Innovator, a Google Cloud Insider, and a Google Cloud Authorized Trainer. He is certified from Google Cloud as a professional architect, a professional security engineer, and a professional network engineer. He's also an associate cloud engineer. He's also the technical reviewer of the packed book, Google Cloud Certified Professionals Cloud Network Engineering Guide. Now tonight, without further ado, let's give it all for Fadi Ibrahim as he begins his workshop. Fadi, up to you.
Hello, everybody. Thank you very much. I am so happy to be with you today. In our workshop, we will discuss how to create a banking as a service using Google Kubernetes engine. I just wanted to be sure you can see my screen and also the Google Cloud platform to start our agenda. Can you see my screen now?
I'm not sure, but I can't see it on my side.
Yeah, I don't see the screen. Could you share?
We just see your camera. Maybe you forgot to share screen.
Could you care to try to share the screen again?
Is it now available?
Yeah, we can see Cloud Platform.
Yes, all good.
Okay,
Looks
this
wonderful.
is the slide. Okay, let's start. Thank you very much for this intro. In our agenda today, we will have an introduction to Google Cloud. We will discuss Google Kubernetes Engine, Microservice Architecture, and our use case, banking as a service. Let's start by Google Cloud intro. In this map, we see the map of the world where each blue dot represents a Google Cloud region. Usually, each region contains 3 zones, and these zones represent Google data centers. Okay, the blue lines represent the fiber optic cables and submarine cables that connect all these data centers together. Okay, we can start by know how the traditional and old data center work. To create a data center, we have to have a lot of servers, each represent hardware, and then we create an operating system or install operating system on this hardware. We are interested about the kernel. It's a part of the operating system that is responsible to manage the hardware. After that, as developers, we develop our application. This is the code of our application. And if we need any libraries or framework, we put our application and its needed libraries over the kernel. over our operating system. To create a data center like that, we may take months for deployment. And we'll see we have low utilization for hardware because our application usually do not take all the CPU and the memory power of the server. And also, if we try to move this application from one server to another, it will be an issue and take a lot of time. After that, people think about virtual machine. In virtual machine, we have a hypervisor. We install a hypervisor over the hardware. The hypervisor allow us to have more than virtual machine over the same hardware. Okay, something like if we want to rent a house, we can rent the house completely, or we can rent the house room by room. And virtually for our client, we let them feel as if they have the entire house. How we can do this? We can have a dedicated entrance to the room, and when he or she enters the room, he have all the infrastructure she need to have its life on the room, from electricity, from water. So as a owner of the room, as the owner of the house, I rent each room alone and make every client from my client feel as if as if she or he have a dedicated house. This idea is used in virtual machine. Now, let's see an example. What if we install two applications on the same virtual machine? In this case, we have application 1 and application 2. What if we make an update to application 1? And this update need an update to a library, which make affect the other application. So maybe the solution that people think about is to put every application in a dedicated virtual machine. On the right now, we do this. We have every application a dedicated virtual machine, but this make another issue. What if we have 100 virtual machine, 100 app? So we will have need 100 virtual machine, and each one of them need a kernel. And what if we need to update the kernel? We have to update 100 kernel. Okay. So this is an issue. We will see how we can solve it soon. Okay, this is example where we have hardware, hypervisor over it, and we have an application that needs 3 virtual machine, one for the web server, another for the database, and the third for the application server. If the load on the web server increase, we can make a solution by creating a new virtual machine that can consume the increase in the load. This can happen when we have in our hardware and our server CPU and memory enough to consume the need of the another virtual machine. Okay, let's try this now on Google Cloud Platform. I will go to Google Cloud Platform. This is Google as cloud provider. The URL is console.cloud.google.com. From here, we can go to the main page. Okay. In the left menu, we have a lot of products, a very category of product, a very huge categories of product. We will start by seeing compute engine virtual machine. This allows us to create a virtual machine. We will see it may take about a minute to create a virtual machine and to put a simple application on it. I will start by click create instance. Okay, I can call it VM1, and here we is the region and its zone. We can keep it on the default. Here also we can choose the CPU and the memory power we need. We can choose anything, and we have a lot of options, but because this is a short demo, I will just allow HTTP traffic and click create. In less than a minute, the virtual machine will be created and there will be a button here, SSH, that allow us to connect to the virtual machine. It will be activated when the VM finishing creation. So I will click on SSH. Can you see the new window of the virtual machine, the created virtual machine? It's just a matter of time and we are connected. This is the command line of the new created virtual machine. I can install a new library just as a web server. Sudo is super user do is like run as administrator. APT is an advantage package that's used on the Debian distributions of Linux, and I use it to install the Nginx web server. Are you sure? I will say I am sure for installing this package. Okay, now we can go here to the external IP. This is the external IP of our virtual machine, and click on it. That will open our application. It's a simple application. It's the default page of the web server. If we have application, we can just copy its code into the web server directory of the virtual machine. So we will see our application here. So this is a very simple example of using virtual machine and installing the needed library to deploy our application. If there is any question now, I can take question before going to the next point. Okay, I will continue if there is no question. Okay, let's speak about another option to deploy an application. We said before that virtual machine takes some time for creation. So it have some issues that we'll try to have a solution for it. We'll solve this issue using containers. Like in this picture, the container protects everything inside it from the outside. Okay, so can we do this in application? Can we make the code of our application and the library it needs in a container separated from any other container or any other process running on the server? Yeah, this can be done. We can look here. We have hardware with hypervisor, so we have more than virtual machine, and this is the kernel of operating system. And then we install a container runtime over the kernel. This container runtime allow us to have a separated user space for each application. Each application and its libraries it needs are separated from other application or are containers running on the same virtual machine. What is the advantage of this? It's lightweight. It need no time nearly to be created. And so the utilization is better, and we can create a lot of containers on the same virtual machine at the same time. Developers usually love containers. Why? Because developers usually have the issue of creating applications that run on their laptops, and when they deploy to the cloud, it does not work. So container solves this problem. How? let's assume the right machine is the laptop of the developer. This is the hardware. This is a kernel of the operating system. And then the container runtime is installed on the operating system. The developer create container for the application and another container for the application. Now, if he try to move the container to the cloud, to the server that running on the cloud, it will be easy to work. Why? Because both of the machine of the developer and the machine on the cloud using the same container runtime. So it will be sure the container will work because it's separated process from any other thing running on the operating system. Let's have another lab. This is Google Cloud Platform. This is the console, which is a web UI that allow us to use all the product, all the service from Google Cloud. There is other option also available to use the service of Google Cloud. One of them is the Cloud Shell. I can click here. To activate the Cloud Shell. Let's know what is the Cloud Shell. Look, Google have what is called Cloud SDK. Cloud SDK is a software that can be installed in any machine. The Cloud SDK, if I installed on my machine, allow me to send command to Google Cloud to use some services or create a virtual machine or any other thing. So Google Cloud make what is called the Cloud Shell. The Cloud Shell is a virtual machine where the Cloud SDK is installed, also with all the software that may be needed. May be needed from you as a developer or a one who deploy a service to Google Cloud. There is also, if I click on the editor here, they will open to me the online editor that can be used while I'm deploying an application to have a look on the code or something like that. Look, we'll start if we go here to the Cloud Console. Here is the project that I'm working now on it. So, like you as a developer who develop an application, for you can make more than project. The same way is here, we can have more than project. So each project can have specific service used and have specific budget. So you can separate it, the resources from project to another. So we are here in the GKE Bank project. I will also in the Cloud Shell let it know I want to use the same project. What is happening here? As we said before, because the Cloud SDK can be installed on any machine, when I try to make a command, I need to log in to my Google account. Because I am logging actually to my Google account, we can see it here. I just click authorized. Okay, now let's try to run a container. I will write what is the command I'm writing now? Docker is a software that allow us to create or use containers. So I'm asking Docker to run a container. The container that I will use is created from an image called HTTPD, which is the Apache web server. Okay. Dash D means the attach. So when I run this command, I will have back the command line, and I will map port 8080 of the virtual machine of the cloud shell to port 80 of the created container, and I just give the container a name. Again, Docker is a software that allow us to create containers, and I am running a new container. This new container is come from the HTTPD, which is an Apache web server. I give the container that I'm creating now the name web server 0 and dash D, the attach, so I can have back my command line. Without dash D, the command line will stuck in executing the command, and I map the port from 8080 to 80. What is this meaning? If I go here and click preview on port 8080, okay, what will happen? This is the Apache web server is now working. So the cloud shell, as we said before, it's a virtual machine. I map the port 80 of the created container to port 8080 of the virtual machine. Now I open the port 8080 on the virtual machine and see my web server is running. I can now create another web server and let it use port 8081, and I will call it web server 1. It's the same command. I will click enter, and now in web review I will change the port to 8081, and this is another web server running on the same virtual machine, and each one is separated because each one is running on a separate container. I can do it again to have 3 web server, and I will change the port again to go to port 8082. Now we have 3 web servers running on the same virtual machine, each run on its own container. Okay, let me know if you have any question for now before we continue to the next point. So we are now giving 2 options: the virtual machine solution and the containers solution. Okay, let's continue. Let's speak about Google Kubernetes engine. Okay, we know that we can use container, but how to manage it when we have a lot of containers? You see me, I am creating containers, then create a next container. This may not be a choice for a production application, which you have to increase the containers by how much load you have, how much traffic you have, and you don't need an engineer sit at the command line to engineer the number or create another containers because you have a lot of traffic. So Google developed what is known as Kubernetes, where we have a cluster. The cluster is more than one machine, and we deploy our containers on this cluster. Kubernetes is open source. It automates everything, and we can deal with Kubernetes either from the command line or writing a declarative configuration in files and say to Kubernetes, execute these files to do what we need. So we will use Kubernetes to manage all our containers. Okay. In Kubernetes, we have some terminology what we need to know. First of them is the pod. The pod, as you can see, maybe have more than one container and shared network between all containers and shared storage between all containers. So we can look at the example on the right. We'll see we have two containers, maybe an old app that needs a reverse proxy. So the two containers are coupled together. So we put both of them in the same pod, and both of them will have the same IP. But how can we identify both of them? It's by using the port number. So each container inside the pod have a dedicated port number, but both of them have the same IP. And also, they share the storage between them. The other two important terminology in Kubernetes are the deployment and services. In deployment, we can look at this example. We can say we need to create a deployment with 3 pods from specific containers. What does it mean? This means the deployment will be responsible if an issue happened to any pod, it will solve the issue. How this happen? It can just kill the pods that have a problem and create a new one. So the deployment will be sure that you have the number of pods that you need, which means the number of containers that you need. Okay? But how this deployment connect to the outside world? This is happened by using the service. The service here can have an IP, and the client use the IP of the service, and then the service send the traffic to the pods. Look, what if we want to make a new version of our application? So this is version 1 and this is version 2. Now, our service send all the traffic to the old version, while the new version now is under test or under quality assurance. And when we are, say let's make our client starting using the new version, we can make the service send a small part of the traffic to the new deployment, the new version of the deployment, the new version of the app. And after some time, if we are okay with the new version, we can make the service increase the traffic more and more to the new version. Okay, this is Kubernetes. Kubernetes, as we said, is an open source and it's available. You can use it on on-prem data center or even on your own machine. So Google go a step and make Google Kubernetes engine. What is Google Kubernetes engine? It automate everything. Why we say we automate everything? Because even in Kubernetes, we have to manage the infrastructure of the cluster. The cluster is created from nodes, it's servers, it's hardware, we have to manage. Google Kubernetes engine also automates this and make it easy to manage, fully manage the cluster nodes instead of the management that the deployer maybe make. So Google Kubernetes engine fully managed, use an operating system that optimize for the containers, and also support auto upgrade. What is the meaning of auto upgrade? Kubernetes can be seen as a software. So when we install Kubernetes on servers, we will be responsible for the upgrade. But using Google Kubernetes engine, it will be auto upgrade. Also, auto repair. If one node of the Kubernetes engine have a problem, Google Kubernetes engine can destroy these virtual machines that make the problem and create a new one. And also support cluster scaling, increase the number of the nodes, number of servers used in your cluster, and it integrates by a lot of servers in Google Cloud. just the networking services, the logging service and monitoring services, and also the cloud IAM, identity and access management, and allow us to use Cloud Console to manage the Google Kubernetes engine. We will see example of the cluster. This is a Kubernetes cluster. We can put the cluster in one zone. So we will have worker nodes where the bots are put here. And also there is a control plan which manages the nodes. The control plan is also virtual machine in Google Kubernetes engine. Also, we can make the cluster in all the region. So your nodes, the worker node, are available in all the zone of the region. What is the difference between both of them? If you make the cluster in all the region, this will cost more, but will be sure even if the rare case when some zone have a problem and be out of services, your services will continue running on other zone of your cluster. Let's have hands-on lab on what we'll say till now. This is the cloud console. We can move here to Kubernetes engine and choose clusters. I can see some question. Yes, I see that question. Is it works the HTTPD image? Yes. This is yes, this is the default page of the web server. Yes. Yes, we use the same image for the same container, and I will let you. We can easily see the image of the container if I Docker image. This is the image we installed. We just pull this image from Docker Hub. Docker Hub is like container hub, like GitHub, but instead of code, it's for container images. And this is the image we pull to create our 3 containers here. I think I answer your question. If there is any other question, let me know. So let's now create a Kubernetes cluster. You are so welcome. I will click create cluster. There is 2 options, standard one or autopilot. From its name, autopilot mean there are some things that will be auto. We will choose GKE standards, and I will say why we will choose this option. I can call the cluster C1. There are a lot of options here, but I may click create directory. This will create the cluster. It will take some time. Why? Because we are creating the nodes. The node, each node is a virtual machine, so it will take some time to create the worker node and create the node that controls the clusters, okay, until we can put our application on it. So let's go back to our slides. Let me know if you have any question till now. We can go back to our slides, waiting for the cluster to be created. Now we will speak about microservices architecture. What is microservice architecture? There is the old way when we put our application is one big part. So there is another way, which is microservice architecture, where we try to make our application contains separated services, and each service or microservices is dedicated for some feature for our application. Okay, let's see an example. Okay, we will see an example of a banking application, a banking as a service. that we divide the banking application to microservices. Let's look here. We have a front end application. Okay. The front end microservices is our web app. So our client, the client of the bank, go to the front end. It's written in Python and it's a web application. Okay. This front end, the user log in here. So when he log in, there is another microservice called the user service. The user service can be sure this is the right user from its username and password. So it will go to the account database. Okay. And the user, the client of the bank, may send some money to another user, which will be a contact to him or her. So if he do this, he will say, I will send $1,000 to my friend Bob. So also there is microservices for contact, okay, and also is connected to account database. So in the front end, I will log in. So I will use user service. I will try to send money to a friend. So I will use contact microservices, which also connect to the account database because my account and the account of my friend are in the account database. If I want from the web application to see my transaction history, there is a microservice written in Java, and this is one of the very interesting features of microservice architecture, where you can create each microservice in a separate programming language. So these are in Python, these are in Java, and actually database can be another one. This can be MySQL. They can't be the same database. So if I want to see all my transaction, I will use this microservices, which connect to the ledger database. And if I want to know my balance now, I can use a microservice that called balance reader that also connect to the database. And if I make new transaction, okay, I will use this microservices that also connect to the database and also update the balance reader microservice. Okay, now when a new user login, okay, it will authenticate. Okay, but because we are making our application separate it into microservices, each microservice need to authorize the user to be sure he or she can use this service. So when the user connect to the user services and the user services know it's and accept the username and the password, it will give her or him what is called JSON Web Token. Okay, and the server here, after accepting the username and password, give him or her the JSON Web Token, and then the client or the browser of the client will use this JSON Web Token to connect to every microservice. And each microservice, be sure he or she have the right JSON Web Token before sending the response. Also, I want you to know the above microservice is just for testing. So it's just a testing framework to test this application. So let's go back to our lab and see. Okay, this is our cluster and now it's created. So I can click here on connect. When I click on connect, what will be happen? We can see here, this is the command line of connection to the cluster. The command line is gcloud. It's mean Google Cloud, which one of the tools available in the Cloud SDK. And then containers. Why we write here containers? Because the old name of the Google Kubernetes engine is Google Container Engine. So the command say container, then cluster. So it means we are speaking now about cluster of Google Kubernetes Engine. Then get credentials. I want to connect to the cluster. I write after that the name of the container and the zone it's R where it is, and the last thing the project. I can copy this command and go to the Cloud Shell. And write the command. This command connect to our cluster that we created. We will deploy our bank application. We can go here to Google Cloud account on GitHub. This is the Google Cloud platform account on GitHub, and search in the repos for the bank. This is the repo we will use. Okay, I will copy the URL of the repo and get here and get clone to copy the repo on my. So now if I make listing, I will see the bank of Antus. This is the repo we will use to deploy our bank application. I will open the editor to see the code. Okay, if you go to the bank of Antus, this fold called extra, and this is the JSON web token here. This is file. I can copy its path, and this is the file. In this file, there is the key used for signing the JSON web token. Because this is the demo, the key put it here, but for sure for production application we can't do something like that. The key have to be secured. I just go here and write kubectl. Kubectl is the command line of Kubernetes. It means Kubernetes control. I will apply what is in this file. What does that mean? We say previously that Kubernetes, we can give it command directly or write a file and tells the Kubernetes to use this file. This is we are doing now. I just tell him to use apply what is in this file to our cluster. Also, we have another folder here. This contains all the bots and all the deployment and service that we will need in our application. I will also copy the path and write and give it the path of the directory. So we can now deploying our application to Google Kubernetes Engine. Okay, we can get bots. So these are the bots we are speaking about before, and they are not ready. As we can see here, they need some time to be to our application to be deployed to our cluster. Okay, we will wait until all our bots, all our microservices, this is the microservice we speak about before, to be ready to see how it works in the browser. Do you have any another question now? I encourage you to asking or have the mic and speak in the mic to ask for anything you need. Let me know if anyone have a question.
Hello, can you hear me?
Yeah.
Yeah, I'm just wondering, I see that you have quite a lot of service running right now, but how do you create these services? I mean, the steps to create.
I can't hear you well. You can try to see it again or write in the chat so I can hear you.
Yes. I'm just wondering if
Okay.
how do you create so many services? I can see so many services are running right now, and how can you create these services in instantly just now? Can you recap one more time?
And, you mean I have an account and my account and Google Cloud, I connected to the credit card so I can use the services? Or you mean you're asking about the time? It's done very fast. Is this what we're asking about? If this is what you are asking about, yes, the services it can be very fast. That when I create a virtual machine, it take no time. Okay, it's usually take about 1 minute or something like that. Uh, no, it's not per project. It charge me by each service. Each service have uh, its uh, it's a price. I will explain to you. If I go here and click on create instance, you will see here the price of this virtual machine. Why is this price? Because if we look here, we have two virtual CPUs and 4 giga memory in which region? In US Central 1. If I change, this is the price per month. Okay. Uh, if we change this to be something like this one, we have here 32 CPU, the price will increase so much to more than $700 because I used a more powerful machine. So it's per services. Okay. Uh, why we have project? Because we maybe create a project for a bank X and another project for bank Y. So each project have its budget and you know how much you have to pay for each project. Okay, look, if you want to manage to host a MySQL database, okay, that's a great question. We have here, we can in Compute Engine create a virtual machine, as we see here, and like I can choose a very small machine, which will cost only uh, like $7 per month. Okay, and you can try. Also, if you, when you create a new account, Google give you about $300 you can use for 3 months. And after you creating a small virtual machine, you can install MySQL. And also Google have a managed services for MySQL. We will need to go to Cloud SQL, and here I can click create instance and choose MySQL. Okay, and this is a managed service for MySQL. What is the difference between this and the previous one? Here, Google Cloud manage the upgrade, manage the backups, manage maybe the high availability if you need. So it gives you a lot of services, not just a virtual machine that will be responsible about and install MySQL and be responsible about the backup yourself. I hope I answer your questions. Now let's go back to the cluster again, to the pods, and see if it's working now. Yeah, all of them are working, and all deployment are working. All of them are ready, and all services are working. And this is the IP, external IP of the front end services. If I go here now and click, this is our application, our bank application. I click sign in. Because this is a very weak password, just Chrome gave me some hint about that. This is the transaction history. There is microservices responsible about this history, and this is the current balance reader. There is a microservice responsible about this. If I try to send payment to Alice, I will give her $100. I click send. You will see the current balance are now decreased by $100, and also in the transaction history there is the amount of our on May 28. This is our transaction we do it now. If I go to our cluster and see our bots, this is the bot of transaction history. Okay, let's try to delete this bot. What do you think? How our application will, how it have? I will refresh the page. You will see the application is running, but just the transaction history is not shown. And if I try to send a payment to another, I will send $200 to Bob and click send. The application is working. You will see the current, because this is a separated microservice from the transaction history microservices. And the good thing, just a matter of time, when the deployment will create a new pod instead of the one I deleted by myself. Actually, in production environment, we don't use one pod. We use many bots. Okay, so if one bot have any problem, the deployment will have enough time to create one instead. Okay, I can go back here and look at our bots again. You will see the transaction history is 0 ready from 1. And if I look to deployment, you will see the transaction history. No, she have to create another bot and be it ready. This will be happen. We have to wait some time, and this will be handled without any interaction from us. Do you have any other question? I encourage you to speak, to take the mic and speak and ask. Okay, the bot is now ready. If I go back here and refresh, they will see that I do not do anything. I do not say create another bot, or I just look if they are working or not, but the deployment create another bot instead of the one that I deleted. And also we make a transaction while the transaction history microservices is out of service. and it's running, I can send the money and my current balance decreased while this transaction history microservices is off. For now, I can say we nearly finish our workshop. I just can take question if you have any.
I think earlier one of the participants wanted to ask, like, I think it was 365 Chan or Michael. He wanted to ask how is there already a lot of services installed or like in the system already? And
Okay.
I think he missed earlier that it was imported from GitHub.
Okay.
Just to
The
clarify.
application is developed. Okay, I do not develop an application. The develop is developed and ready to be run. Okay, so I go as you said. We go to the GitHub and if you remember, this command git clone. I clone the repo of the application, and when I clone it, it's here. This is the application. All what I do is let him know the key that will be used in authentication. Okay, and then this folder contain all the configurations that Kubernetes needs to create the bots and services and the deployment. Uh, as we said before, Kubernetes allow us to configure it by command line directly or write configuration in a declarative way in a files, and they set to Kubernetes to uh, execute these files. And this is what we do. Okay, we have a developed application. It's ready to be used in to create the banking service. Okay, I hope I answer the question. Okay, okay, this is a very good question. We have to create a Docker file. If you have a Node.js server application, we just in your folder create a Docker file, and in this Docker file, you can create a container image. Okay, that we can after that use in Google Cloud. So all what you need to do is create a Docker file and let the Docker file know how to create the container image from your code. And when your container image is ready, you can use it on Google Cloud. Any software can be easy, generally speaking, can be converted to Docker image. Look, this is the front end microservices. There is here file called Docker file. In this Docker file, if I click, there is some code we have to write or some configuration we have to write. So I like you see here from this is the image, the original image that is used in this application, the front end application. Okay, it's like instantiate an object from a class. So it's now known in the front end use Python, and this is version. And you write some configuration to say you will use a specific directory and put some environment. Okay, and after that you can create the image and put it in Google Cloud or in everywhere else. Okay, we can. There is books about microservice architecture. We can start by reading books about microservice architecture that help us to think how to create microservice architecture. But in short way, the idea is to divide the big application to separated part. So when one part is off or out of service, other part can continue running, like our demo here. When the transaction history is out of service, other service can run and can do what it have to do. So you can start reading books about microservice architecture. There are many of them, and uh, anything come by trying it, and it will be easy. On GitHub also you can have uh, some repos that show examples of microservices and how it created.
All right, let's have one or two more questions left as we're running low on time. I guess like maybe Fadi, I'll ask you this because a participant asked earlier, but it's a bit higher up. What are some other practical examples of the microservice architecture besides the banking demo we saw? Can you give us another example?
Another example, maybe an edu example, education, university. Your university can use use microservices in its portal or its website, and instead of use every the application to be one big application, they maybe microservices about providing the question in exams, microservices about logging the students or the staff, maybe microservices about choosing the result of the exam, maybe microservices about chatting or messaging between a student or forums. Instead of making all the application of your university as a one huge application, we can divide it to microservices. Microservices can use in a lot of industries and a lot of examples.
That's a very good example.
Okay, thank you very much.
Do we have one more question?
Yeah,
Anyone?
sure. Yeah, you can ask.
Well, I guess if no one wants to ask, I guess like a little follow up on that. That was the example you gave how university systems can incorporate microservices architecture. I think that's a good idea, but I did notice that at least in Poly, some of the systems like Blackboard or even we use another, I forgot, like it's another website. They're all just one system, and when it goes down, the whole application goes down. Why do you think microservice architecture is not widely adopted? I don't see it as often.
Okay. Because it's a new thing. If you compare it to the old way, also you need to refactor the code. You have application, usually maybe you have an old application, and when you think in a move to microservices, it means you have to have a budget to this move. Okay, so it's a new thing. Usually people do not go to the new thing very fast, and you have to have developers and architects to have to create the microservices, and also you need budget to refactor the old code and old application to it a new way. So this may be make moving to microservices a little bit slow.
Understandable. Well, thank you very much, Fadi, for that wonderful answer. And thank you very much for your time, everyone. Let's give Fadi a round of applause
Okay.
for this amazing
Thank you.
workshop.
Thank you.
It was very educational. I learned a lot. Yes.
Thank you. Thank you. I am very happy to be with you. It's my pleasure.
Oh, no, it's
I
our
say-
pleasure to have you too.
Thank you very much. I am very happy.
Yeah. And I hope everyone over here tonight, you can apply what you've learned into your hacking projects. Thank you very much for coming, everyone, tonight, and look forward to our next workshop, our next technical workshop on blockchain.
Sure, it will be my pleasure.
Oh, yes, please do so.
Okay, thank you. I am so happy again and wish to you see you again. Bye bye. Have a nice day. Bye.
Have a nice day, too. Good night, everyone, in this side of the world.
Yeah,
Thank you, Todd.
thank you. Thank you. Thank you to all of you.